okay? I'm hoping you watched the video on completing the square. This is the second one, okay? But it's about solving equations using the method of complete the square to do that, okay? So first video was showing you how to complete the square. Now I'm going to talk you through how to actually solve an equation by this method. So here's an equation, okay? Before it's expressions, but when you put an equal something, now it becomes an equation, okay? So complete the square to solve that equation. Pause the video, okay? Try and see if you can do it, then unpause it. Okay, so x plus 4 squared, hope you're happy with that. Of course, you just halve the coefficient, okay, to get 4, okay. And then I'm going to subtract 16. You happy with where the 16 comes from? So I'm just going to square the 4 to get 16, okay, and then add on 10 equals 0. In case you skipped the first video, why would you want to do that? Go back and watch it, okay. But in case you really can't, because literally I can't make you, can I? Okay. In case you just need a quick recap of that, okay. So we're trying to get this, okay. This bit here gives us the x squared plus 8x plus 16. That's the brackets if you want it expanded. Okay, if I subtract 16 again, I get x squared plus 8x and then plus 10. Can you see that these two are exactly the same? Okay, and that's why I'll be using that method. Okay, so the x plus 4 squared, the brackets are needed just to get the perfect square bit, and then you add or subtract the number that you need. Okay, right. And if you still don't understand that, then really go back and watch that first video. Okay, right. So let's just tidy that up. X plus 4 squared, and then subtract 16 plus 10. That's subtract 6. Okay, I don't need that step. I'm just putting it in. Okay, and then put everything onto the right and put the numbers. Constant onto the right hand side, you get that x plus 4 squared equals 6. Okay, and then you solve it. Okay, this is a bit like making x the subject now. Okay, you want to get x on its own, so the first thing you want to do to both sides is take the square root of both sides. So x plus 4 is equal to positive or negative root 6. Do not forget the positive or negative, it's important. Okay, you remember that the vast majority of quadratics that you end up solving, I've got two solutions, okay. Some of them have got one solution that's repeated, some of them have got no real solutions, okay. But the vast majority of equations you solve will have two solutions, okay, and they'll be real for A-level maths, okay. So you've got positive or negative root 6. Do not write down the decimal equivalent, okay. Do not do that, okay, because we're not in GCSE maths anymore, okay. We're in A-level maths. We want the exact answers, okay. And the exact answer of root 6 is root 6. We did a whole unit on surds in chapter 1, okay, so hopefully you appreciate the reasoning for keeping that as root 6, okay. And then we'll put the 4 on the other side, so that's x equals negative 4, and then we've got plus minus root 6, okay, and that's our solution, okay. If you want, work out the R to 3 significant figures, okay, just write down equals, and then the 2 plus or minus 3 significant figures, I'm going to leave it like that, okay, because it's in its exact form, which is preferable, okay. The only times you'd realistically want to get a decimal equivalent is if you're plotting points on a graph, okay? Because then it's handy to know what the approximate value is, okay? Anyway, that's one example of completing the square. Let me give you another one. Let's just rub this off. Okay, and there we go. There we go. And let me just give you another example of completing the square, okay? I prepared it earlier, so I'm just going to read from what's in front of me, if you don't mind. Okay, so 2x squared plus 10x, and then plus 12 equals 0. Okay, maybe just pause the video and have a go. Do that. Okay, great. Right, the first line of working preferably should be this. Did you do that? Well done if you did. If you didn't, well, when you're solving an equation, if you notice there's a common factor you can take out or divide throughout by, okay, do that, okay. You can see factor 2 there in each of those 3 terms, divide everything by 2, okay, it makes it easier. My advice to you is, when you're completing the square to solve a quadratic, always divide by whatever the coefficient of x squared is, if it's not 1, okay, because you want to have 1 x squared there, just an x squared term, the coefficient of 1. Okay? So my advice is, if ever you did, look, in general, okay, if your quadratic is this, x squared plus bx plus c equals 0, divide throughout by a, okay, divide that by a, because then you'll get x squared on its own, okay? Even if this term turns out to be more difficult, okay, and even if that turns out to be more difficult, it's going to be easier to complete the square, and it's just 1x squared. I hope you agree with me, okay? Right, back to this, okay? Maybe if you didn't do that, you just pause the video again and rework it, okay? Have you done that? Right, so x plus 5 over 2 squared, okay? Because, as I said, you always halve the coefficient of x, so halving it is 5 over 2, okay? I said about fractions, didn't I, in the previous video? Yep, avoid decimals at all costs when you're solving equations, okay? So 5 over 2, and then subtract 25 over 4. See how quick that was? Because it's great, isn't it? I mean, the decimal equivalent of that is 2.5, okay? Okay, you could write it as a mixed number, 2.5. But when you're squaring this, you know, when you're squaring that, can you do that quickly in your head? Okay. Let me give you another example, okay? So 81 over, so let's just do 144. If I do the square root of that, can you do that? Okay, yeah, square root of 81, square root of 144. Now turn that into a decimal, 81 over 144. Look at the decimal equivalent. Can you do the square root of that? Yeah, so yeah, there's all sorts of examples I can show you as to why fractions are better, okay? Because it lends itself well to being able to calculate things quickly in our heads. Okay, anyway, it's not a lesson of fractions, okay? Let's continue this. So subtract the square of that, so subtract 25 over 4, and then you've got the plus 6 equals 0. Then we just want to tidy that up a little bit. So x plus 5 over 2 squared. I'll tell you what, I'm going to write it like this, okay? Because, you know, from year 7 you should remember when you're adding or subtracting numbers, okay, in fractions involved, go for a common denominator. Okay? 4, okay, so 24 over 4 is the same as 6. So x plus 5 over 2 squared. Now 25 subtract 24 is 1. Okay, so you got that. Okay, and then you want to put the quarter onto the other side. Okay, so that's 1/4, and then square it both sides. So x plus 5 over 2 is equal to plus or negative, positive negative half. Okay, and then we just put that over to that side. Okay, so you're going to have x is equal to negative 5 over 2 plus minus 1/2. I almost wrote it like this, okay? I almost wrote it as negative 5 plus minus 1 all over 2. Yeah, almost wrote it. I have actually written it like that. Okay. Either one is fine, okay? But basically what we're going to do is you're going to do negative 5 over 2 plus 1/2, or negative 5 over 2 subtract 1/2, okay? Or negative 5 plus 1 divided by 2, negative 5 subtract 1 divided by 2. Okay. So let's just do this one. Okay, the first one I wrote down. Negative 5 halves plus 1/2. So it's negative 4 halves, negative 2. Okay. Negative 5 halves, subtract 1/2, that's negative 6 halves, it's negative 3. Okay. That's it. Okay, you get answer negative 2 or negative 3. Okay. We can check that, of course. I didn't mention this in any of the previous videos, but you can check it. You should be able to substitute in either solutions into your original quadratic there, or there of course, but the original is probably best. And as long as you get equals 0, should work. Okay, do that if you want. If you don't get equals 0, you've used your calculator wrong. Okay. Alternatively, if I go back to the very beginning, this one, I've actually given you one that factorise. Okay, it will actually factorise. Maybe some of you spotted that straight away. Okay, x plus 2, x plus 3 equals 0 is how that one factorises. Okay. And that just confirms really two answers, negative 2 or negative 3. But the reason I did that is I didn't want it to be too complicated an example. Okay, I'm hoping you found that useful. Okay, and I hope you're getting all the extra practice questions you need to be doing. Okay, remember this is only chapter 2 of what's going to be a nice long course.